Hello everyone, my name is Nidhi Singh. I'm assistant professor in the Institute of Pharmacy. It's a part of Suresh Gyan Vihar University, Jaipur. So today we are going to discuss this topic that is carboxylic acid, and in carboxylic acid, as we were discussing about the carboxylic acid and its derivative. So it is new pharmaceutical organic chemistry first. Let's start the topic. So the learning objective of this topic is that here we are going to learn about the carboxylic acid derivatives. Also, we are going to study about the chemical reactions of carboxylic acid. Means here we have already discussed the chemical reaction of acid chloride. So today we are going to discuss the uh, chemical reactions of your esters, your acid anhydrides, and the amides. So here we are going to discuss about the chemical reactions of carboxylic acid derivatives, and the student outcome is that they are going to know about the carboxylic acid derivatives, plus they will also learn about the chemical properties of carboxylic acid derivatives. So next, here the introduction of this topic is that the most important functional derivative of carboxylic acids are acyl chloride, your acid anhydride, esters, and your amides, which are obtained by the replacement of OH part of carboxylic group of acid by Cl, OCOR, OR dash, or NH2 group respectively. So here the functional derivative of carboxylic acids are acyl chloride, acid anhydride. Means here the carboxylic acid, that is a combination of your carbonyl part and the hydroxyl group. So that combination of this carboxylic acid, from this carboxylic acid there is a formation of your or this acyl chloride, acid anhydride, esters, and amide. So in these all derivatives there is a this replacement, there is a replacement, and from here the replacement of OH group. So in all the carboxylic acid derivatives, the OH group is replaced by your Cl, OCOR, OR dash, or NH2 group. So in this, the first derivative of this carboxylic acid derivative is the acyl chloride, in which the OH group is replaced by a Cl part, and in the second, that is your acid anhydride, in which the OH group is replaced by your OCOR. So here it is your acid anhydride. So in the ester, the OH part is replaced by your OR part. And in this, the both R can be different or can be same. And the next, that is your OH. In the fourth derivative, the OH is replaced by your NH and it becomes your amide. So in the acid chloride, the functional group of acid chloride is RCOCl, which is formed by the replacement of OH from the carboxylic acid by your chlorine, that is your Cl or any other halogen. So next is your RCOOCOR, that is your acid anhydride, which is formed by the which is formed by the replacement on carboxylic acid by OH group by acyl oxy. Next is your um, Next is your OH. Next is your esters, in which the ester is replaced in ester. The OH part of the carboxylic acid has been replaced by your or alloxy part. That is your alloxy part is your OR. And in this, the last, the amide, that is the carboxylic acid. That is also the most important functional derivative of carboxylic acid. In this also, the amide, the OH part is replaced by the NH2 part with the carboxylic acid. So here, these are the four important functional derivative of carboxylic acid, that is your acyl chloride, acid anhydride, esters, and your amides. Next is the acid anhydride. So in the last lecture, we have already discussed about the chemical reaction of your that acid chloride, or you can say acyl chloride. So in this, the acid anhydrides are less reactive than acyl chloride towards nucleophilic substitution. So in this, acid anhydrides are less reactive than acyl chloride towards nucleophilic substitution, and the most common acid anhydride is acetic anhydride, and the important chemical reaction of the acid anhydrides are hydrolysis. So here, acid anhydrides are less reactive than the acyl chlorides. So acyl chlorides are more reactive towards the nucleophilic substitution, and but in case of your acid anhydrides, these are less reactive towards the nucleophilic substitution, and the most common acid anhydride is your acetic anhydride, and so here the most common acid anhydride. So it is the first function. It is the first member of this acid anhydride group. So in this, the acid anhydride, the first member is your acetic anhydride, and the first reaction of this chemical reaction of this acetic anhydride are hydrolysis. So in this, acid anhydrides are hydrolyzed with water to acid. So in this hydrolysis, the acid anhydrides are hydrolyzed with water to acids, and here CH3CO whole plus O plus H2O, it forms acetic acid. So in the hydrolysis, the acid anhydrides are hydrolyzed with water and hydrolyzed with water to acids, and there is a formation of this acetic acid. So from this acetic anhydride, this when there is a hydrolysis in the acetic anhydride, there is a formation of this acetic acid, which is the parent carboxylic acid, and from this carboxylic acid, there is a formation of this acetic anhydride. So in the reversible, it is this acetic anhydride is forming the acetic acid. So this is the first reaction, and the acid anhydrides are the less reactive than acyl chloride towards nucleophilic substitution. And the most common acid anhydride is your acetic anhydride, and the most important chemical reaction of this acetic anhydride are your hydrolysis. And the first reaction of this chemical reaction of the acetic anhydride are hydrolysis, and the acid anhydrides are hydrolyzed with water to acid, and this acetic anhydrides react with your hydrolysis with the water. There is a formation of acetic acid. Next is the alcoholysis. In your alcoholysis, this acid anhydride is reacting with the ethyl alcohol, and there is a production of this ester. So from this acid anhydride is reacting with this ethyl alcohol, and there is a production of this ester. So this acetic anhydride is reacting with ethyl alcohol. So from this ethyl alcohol, and there is a formation of this ester plus acetic acid. So here the alcoholysis is happening. Means here alcohol is breaking, or else there is a lysis, means there is a break in this ethyl alcohol, and there is a formation of this after the break on this alcohol, there is a formation of a ester is formed here, and your acetic acid is formed here. So in this alcoholysis, the acid anhydride is reacted with this ethyl alcohol, and there is a production of this ester plus acetic acid. So this acetic anhydride, this is a CH3CO whole twice O plus C2H5OH. C2H5 is the ethyl alcohol, And here there is a alcoholysis occurring, and there is a formation of this ethyl acetate plus acetic acid. So how it is formed? You can see here that acetic anhydride is having this CH3CO whole twice O and C2H5OH. And in this, the ethyl alcohol is there is a formation of this ion, that is the C2H5 positive and OH negative. So in this CH3COO, so it is having the negative charge, and this CH3CO is having the positive charge. So here the H, that is your, sorry, here there is a removal of the C2H5O, and there is a H positive is removed out from here. No, OH is removed out from here, and this OH negative will react with this CH3CO, and there is a formation of this acetic acid. And there is a formation of the and methyl acetate is formed from the CH3COO. Negative will react with this C2, a positive will react with this C2H5O, and there is a formation of this ethyl acetate. So in this alcoholysis, this acid anhydride is reacting with this ethyl alcohol, and there is a production of this acid. So acetic anhydride is reacting with the ethyl alcohol, and there is a formation of this ethyl acetate plus your acetic acid. So in the ammonolysis, now next is your ammonolysis. So in this, there is a lysis of this ammonia. So in this, ammonia rapidly react with acetic anhydride, and there is a formation of this acetamide. So acetic anhydride plus ammonia, there is a formation of this acetamide plus acetic acid. So here you can see there is a formation of this acetic acid. In your acid chloride, there is a formation of axial mode in all of the reaction except few of them. So here also you can see there is a formation of this acetic acid is occurring here. So in this, the ammonolysis, there is a lysis of this ammonia. So this is your acetic anhydride, and acetic anhydride is reacted with the ammonia, and there is a formation of this acetamide acetic acid. So in this acetic anhydride plus ammonia, that is your CH3CO whole twice O plus NH3. So in this acetic anhydride is reacting with the ammonia, and there is a formation of this acetamide. So here this acetamide is formed here. So as you can see in the from this acetic anhydride, there is a formation of ester plus there is a formation of this acetamide. So so from this, the other derivatives of this carboxylic acid are also formed from this acid anhydride. So ammonia rapidly react with this acetic anhydride and give acetamide. So here in this, this COO, one CH3CO is reacting with this NH2, and there is a formation of this acetamide, and the another CH3COO is reacting with the H of this ammonia, and there is a formation of this acetic acid. So in the ammonolysis, there is a formation of the acetamide plus your acetic acid. So in the alcoholysis, the acid anhydride is reacting. Alcoholysis, the acid anhydride is reacting with the ethyl alcohol plus to produce ester. So in this case, the acetic anhydride is reacted with the ethyl alcohol. Means there is a lysis of this alcohol, and after the lysis of this alcohol, there is a formation of the ethyl acetate plus your acetic acid. And in the third, that is your ammonolysis. In that, the acetic anhydride is reacted with the ammonia, and there is a formation of this acetamide plus your acetic acid is formed here. Next is your fourth, that is the action with primary amine. So in this primary amines, the primary amine is reacting with the acid anhydride, and there is a formation of the amides. So in this, the action with primary amine means here the primary amine is reacting with this acetic anhydride, and there is a formation of this amides are forming here. So in this case, this is your primary amine, and in the Ammonolysis, there is a lysis of this this ammonia, and there is a formation of this amine. So in this also the primary amine is reacting with this acetic anhydride, and there is a formation of this is acetamide. So in this action with primary amine, the primary amine is reacting with acid anhydride, and there is a formation of this amine. So acetic anhydride is reacted with this ethyl amine, and there is a formation of this N-ethyl acetamide. So in this, you can see there CH3CO whole twice O, that is your acetic anhydride, plus ethylamine, that is C2H5NH2, and there is a formation of this N-ethyl acetamide plus acetic acid. So acetic anhydride plus ethylamine. So it is having C2H5NH2, and this C2H5NH2, it is reacting, means here from this ethylamine, the H is removed out from here, so the proton is removed from here, so it is getting the negative charge, and the proton is getting the positive charge. And this positive charge of proton will react with the CH3COO negative, and there is a formation of this acetic acid. Acetic acid is formed there, and after that, this CH3CO react with this NHCH2 C2H5. So here you can see in this the primary amine is reacting with this acetic anhydride. In this, the two molecules of the CH3CO is attached to this oxygen, and here the one molecule of this CH3CO will react with this H, which is removed out from this ethylamine, and there is a formation of this acetic acid, and from this acetic anhydride CH3CO will react with this NHCH2H5, which is having the negative charge. So here this is having the N-ethyl acetamide is formed from this acetic anhydride plus ethylamine, and plus acetic acid is also formed there. The acetic acid is the parent carboxylic acid. So from this the acetic anhydride is formed, and now the from the acetic anhydride this acetic acid plus the acetamide is formed. And acetamide, this is your amide, which is one of the carboxylic acid derivative of this carboxylic acid derivative. Next is the reduction. So in the reduction, you can see we are doing reduction with the lithium aluminum hydride and plus sodium and alcohol, and acetic anhydride produces alcohol. So on reduction with this lithium aluminum hydride with or sodium and alcohol, acetic acid produces alcohol. So acetic anhydride plus your hydrogen 8 plus lithium aluminum hydride in the presence of this catalyst, that is your lithium aluminum hydride or sodium alcohol, there is a formation of this alcohol plus your water molecule. So on reduction, we are doing here reduction. So reduction means here addition of hydrogen. So here the addition of hydrogen is occurring, and when the hydrogen is adding to it, there is a formation of this this alcohol is formed here plus your water molecule. So how this is formed, you can see here this is a CH3, and here two molecules of this is given CH3CO. So here you can see here CH3. So here two molecules means C2H6 is here. So from here C2H5 plus your OH is formed here as C2H5, and from another there is a removal of this hydrogen, means from here H2O is formed here. So here C2H5 O plus OH means here two molecules of this C2H5 OH is formed plus your H2O is formed, and so here you can see this is your alcohol, and this is your water, which is formed on reduction, means here addition of this hydrogen is adding to this reactant, and in the presence of this lithium aluminum hydride plus your sodium plus your alcohol. So here acid anhydride is reacting with the ethyl. So in the second reaction, alcoholysis, in this acid anhydride is reacting with this ethyl alcohol, and there is a production of this ester. And second acetic anhydride plus your ethyl alcohol is reacting, and there is a formation of this ethyl acetate plus your acetic acid is formed. Next is the ammonolysis. In the ammonolysis, you can see the ammonia is rapidly react with your acetic anhydride, and there you give the acetamide. So in this acetic anhydride plus ammonia plus here there is a lysis in this ammonia, and there is a formation of this acetamide plus your acetic acid is formed here. Next is your action with primary amine. So in this primary amine react with your acid anhydride, and there is a formation of this amide. Next is your acetic anhydride plus ethyl amine. So there is a formation of this N-ethyl acetamide, and acetic acid is formed here. So in this acetic anhydride plus your ethyl amine is reacting with this reacting, and both of them are reacting, and there is a formation of this secondary secondary amide. So here this is your N-ethyl acetamide plus your acetic acid. Next is your reduction. So on reduction with your lithium aluminum hydride, which is your catalyst, and or sodium. So you can use your sodium also, plus your alcohol. Alcohol also we are using here. And after that there is a reduction, and there is a reduction in this acetic anhydride, and there is a production of this alcohol. So here two molecules of this ethyl alcohol is formed, plus your water molecules. Next is your Friedel-Crafts acylation. So in the Friedel-Crafts acylation, the acetic anhydride is on reacting with the benzene in presence of the anhydrous AlCl3 from aromatic ketone, and there is a formation of this there is a formation of this ketone. Aromatic ketone is formed here. So here you can see this is your benzene, that is your aromatic hydrocarbon, and when we are reacting this acetic anhydride with this benzene, there is a production of this ketone, that is your aromatic ketone. So on this benzene plus acetic anhydride, which this reaction is occurring in the presence of your AlCl3, that is aluminum chloride, and there is a formation of this C6H5COCH3, that is your acetophenol, and this acetophenol is a aromatic hydrocarbon plus your acetic acid is formed here. So in this the acetic acid is formed here. So in this the Friedel-Crafts acylation, the acetic anhydride on treatment with your benzene in the presence of your anhydrous AlCl3, that is aluminum chloride, there is a formation of this acetophenol plus your acetic acid is formed here. So here you can see this is your benzene and this acetic anhydride, and anhydrous AlCl3 plus acetophenol plus acetic acid. So on this benzene molecule, you can see this CH3CO is whole attached to this here, and after that the remaining CH3CO is react with the hydrogen, that is your proton, that is removed out from here from this benzene. After that there is after the removal of this H positive, means here this COCH3 is attached to this molecule of this benzene, and here H positive is also present. So we have to remove this H positive to make the stable molecule. So here the H positive, that is your proton, which is removed out from this benzene, that will react with this CH3COOH. And there is the formation of this acetic acid is formed here. So in the Friedel-Crafts acylation, acylation means here there is a reaction on this aromatic compound, means here on this benzene, aromatic hydrocarbon. Benzene is also an aromatic hydrocarbon. So here acylation means in the Friedel-Crafts acylation, the acylation is happening on this acyl group, or you can say the aromatic hydrocarbon, or you can say the benzene, and this Friedel-Crafts acylation occurs in the presence of this catalyst, that is your anhydrous aluminum chloride. And here when this anhydrous AlCl3 is present in the reaction of this benzene plus acetic anhydride, there is a formation of this Acetophenol plus acetic acid is formed here. Next is the action with phosphorus pentachloride. So in this, there is a action of this phosphorus pentachloride, means the phosphorus pentachloride is acting on the acetic anhydride, and there is a formation of this acetyl chloride plus phosphorus oxytrichloride. So here this acetic anhydride is reacted with this phosphorus pentachloride, and there is the formation of this acetyl chloride. Acetyl chloride is formed here, plus your phosphorus oxytrichloride is formed here. So here you can see this acetic acid is reacting with this PCl5. This acetic acid is reacting with this PCl5. After that, this from here one Cl is removed, that is having the Cl negative, and this Cl negative will react with this CH3CO, the two molecules, same two molecules. So from here, the two molecules of this Cl will be removed out from here, and this will react with this CH3CO, and after that this oxygen is remaining, and this oxygen will react with this POCl3. So POCl3 is formed here. So here acetic anhydride is reacted with this POCl5, and there is the formation of this acetyl chloride plus phosphorus oxytrichloride. Next is the action of chlorine. So here the action of chlorine means the chlorine is reacting with this acid anhydride. So acid anhydride is reacting with this chlorine, and there is a formation of this acetyl chloride and monochloroacetic acid. So acid anhydride is reacted with this chlorine, and there is a formation of this acetyl chloride and monochloroacetic acid is formed here. So this acetic anhydride is reacted with this chlorine, and there is a formation of this acetyl chloride plus your monochloroacetic acid is formed here. So as you can see here, the acid anhydride is reacted with this chlorine, and there is a formation of this acetyl chloride plus monochloroacetic acid. So here you can see there is a chlorine, Cl is formed here, and this CH3CO whole twice oxygen is reacted, and there is a formation of this acetyl chloride is formed here. So this CH3CO is reacted with this chlorine, and one molecule of chlorine is left, which will react with this CH2 COOH. So here the CH2 COOH, it will react with this remaining CH2COOH. So from here the H will remove, and it will react with this oxygen, and here this oxygen is having less one bond, so it will react with this chlorine, and there is a formation of this monochloroacetic acid. So this is a so in this first was your Friedel-Crafts acylation. In the Friedel-Crafts acylation, the acetic anhydride is reacting with the benzene in the presence of your anhydrous AlCO3, and there is a formation of this ketone plus your acetic acid. Next is your action with phosphorus pentachloride. The acetic anhydride is reacted with this phosphorus pentachloride, and there is a formation of this acetyl chloride, which is your acid chloride, and first derivative of the carboxylic acid plus your phosphorus oxytrichloride is formed here. Next is your action of chlorine. So in the action of chlorine, the acid anhydride is reacting with this chlorine, and there is a formation of this acetyl chloride, and monochloroacetic acid is formed here. So here you can see acetic anhydride is reacted with this chlorine, and there is a formation of this acetyl chloride, and monochloroacetic acid is formed here. When we are reacting with this chlorine, when we are reacting with acetic anhydride with the chlorine, there is a formation of this monochloroacetic acid is formed here. Next is the action with dry hydrogen chloride. Means here dry hydrogen chloride, on reaction with your dry hydrogen chloride. So there is a formation of this acetic anhydride formed from acetyl chloride and acetic acid. So this acetyl chloride is reacting with this acetyl chloride, and acetic acid is formed here. So similarly, on reaction of this acetic anhydride with this HCl, there is a formation of this acetyl chloride plus your HCl is formed here. So your acetic acid is formed here. So in this also the acetyl chloride, your anhydride is forming a first derivative of this first functional carboxylic acid derivative, and that is your acid chloride. And in this, the chlorine is attached to the your CH3COCl part. So there is a formation of this acetyl chloride plus your acetic acid is also formed here. So here you can see in this reaction, you can see the action with dry hydrogen chloride. Means this dihydrogen chloride is acting on this acetic anhydride. So this acetic anhydride you can see on reaction with dihydrogen chloride, acetic anhydride forms acetyl chloride plus acetic acid. So here acetic anhydride plus HCl. So this acetic anhydride plus HCl is reacting with this acetyl chloride plus CH3COOH. So here you can see this HCl. So this H is reacting with this CH3COOH, and this CH3CO will react with this is Cl part. So this CH3CO will react with this Cl part, and there is a formation of this acetyl chloride and acetic acid. This acetic acid anhydride are used in the preparation of your amyl acetate, aspirin, dyes, also acetate rayon, and they are used as acetylating agent. So this acid anhydride are used in the preparation of your amyl acetate. Means this amyl acetate is also this amyl acetate is also formed from this acid anhydride plus your aspirin plus some of the dyes also formed from this acid anhydride, that is your acetic rayon, and these are also used as a acetylating agent. Means here it is used as an acetylating agent. Next is your esters. So the esters are less reactive than the acyl chloride and acid anhydride. As you can see, the acyl chlorides are more reactive, but then this acid anhydride, and this esters are also less reactive than this acyl chloride and acid anhydride. So methyl methonate and the ethyl ethonate are the first member of this is ester group, and these are the most common esters. So methyl methonate and the ethyl ethonates are the common esters. So they are converted into carboxylic acid. So they esters are converted into the carboxylic acid by acid or base hydrolysis into amides with ammonia, and can be reduced into alcohol with lithium aluminum hydride. So first reaction is your hydrolysis. So in the hydrolysis, esters are hydrolyzed to carboxylic acid in presence of an acid, whereas in presence of alkali, they produces sodium salt of carboxylic acid. So in the ester, in the hydrolysis, these esters are hydrolyzed and they form the carboxylic acid in the presence of an acid. But in the presence of the alkali, then they form the sodium salts of your carboxylic acid. So esters on the presence of an acid, they are forming carboxylic acid, but in the presence of the alkali, they are forming the sodium salt of your carboxylic acid. So in the first is the acid hydrolysis. In this, you can see the ethyl acetate plus water molecule. In the presence of your acid, they are forming the acetic acid plus your ethanol, and in the alkaline hydrolysis, this ethyl acetate is forming a NaOH in the presence of this NaOH, which is your alkali, and there is a formation of this sodium acetate plus your ethanol is formed here. So here the sodium salt of carboxylic acid is formed here. Next is your action of ammonia. So in the action of ammonia, ester slowly react with ammonia, and there is a formation of these amides and the alcohol. So esters are slowly reacting with the ammonia, and there is a formation of these amides and alcohol. And this process is called as ammonolysis. So in the action of ammonia, esters are slowly reacting with this ammonia, and there is a formation of this amides and alcohol, and this process is called your ammonolysis. So this ammonolysis we have already discussed in the these are not same, but in this ammonolysis we have also discussed in the acid anhydride. In that also there is a formation of this acetamide. And here also in the esters are slowly reacting with the ammonia and they are forming the amide plus your alcohols, and this process called as ammonolysis. So in the ethyl acetates are reacting with this NH3 and there is a formation of this acetamide plus your ethanol is formed here. And in the mechanism you can see that this is your ethyl acetate and this ammonia is having the lone pair and it is getting reacted to this chlorine which is having the positive charge because oxygen will withdraw the electron from it and there is a formation of this acetamide and from here the H will be moved out and it will react with this OC2H5. So here you can see that this oxygen is having the positive charge and this oxygen is having the negative charge, having the lone pair and it will withdraw electron from here and it will get the partial negative charge and this will get the partial positive charge. So this NH3 which is having the lone pair will react with this carbon atom and it will get the positive charge on it. So this is having the positive charge in this carbon which is already attached with this oxygen. So here there is a positive charge on this. So to remove, to become stable, this H, this proton will remove out from here. So here H positive will remove out and from here to form a stable bond because here there is a this will give its electrons to this carbon now. So here the from this OC2H5 this is will move out from here. So here the positive charge will come on this carbon. So this oxygen will give its bond again, give its electron to this carbon, share electrons with this carbon atom, and there is a formation of the double bond. And this OC2H5, which is having the negative charge, it will react with this proton that is removed out from this ammonia, and there is a formation of this acetamide plus ethanol is formed here. Next is your reduction. So on reduction with lithium aluminum hydride or sodium or alcohol esters become produces your alcohol. So ethyl acetate is reacting with this lithium aluminum hydride or sodium or alcohol. There is a formation of this ethanol. Next is your halogenation. So in the halogenation, esters on reaction with chlorine or bromine in presence of your red phosphorus give the alpha halogenated esters. So in this, the esters on reaction with this chlorine or bromine in presence of your red phosphorus give the alpha halogenated esters, and this ethyl acetate is reacting with this bromine in the presence of this red P. There is a formation of this alpha bromo ethyl acetate is formed here. And next is your Claisen condensation. In the Claisen condensation, one hydrogen of an ester combines with the second molecules of the ester in presence of sodium alkoxide, and here it gives an aldehyde or an ketone. This reaction is known as Claisen condensation. So in the Claisen condensation, the two molecules we have taken the two molecules of esters because where the one molecule of ester will combine with the second molecule of the ester in the presence of sodium alkoxide. So sodium alkoxide is C2H5 CoNH and A, and here it is giving a ester or your ketone or your aldehyde. So the reaction is known as your Claisen condensation. So here you can see this is your two molecules of this ester, and these are the two molecules of your esters, and this is reacting in the presence of the sodium alkoxide, and there is a formation of this ethyl acetoacetate. So this ethyl acetoacetate is formed in which the ketone molecule is present. So there is the formation of this ketone or an aldehyde. Next is the action of phosphorus pentachloride or thionyl chloride. So here you can see the this ester is reacting with this phosphorus pentachloride plus there is a formation of this acid chloride. So there is a formation of this acid chloride formed here. So in this phosphorus oxytrichloride is formed plus RCl is formed here. So in esters, we have taken the example of this ethyl ethanate, and this ethyl ethanate is reacting with this SOCl2, that is your ethionine chloride, and there is a formation of this acetyl chloride. Plus your ethyl chloride is formed here, plus SO2 is formed here. So next is the ethyl ethanate is reacting with this PCl5 that is your phosphorus pentachloride, and there is a formation of the acetyl chloride plus ethyl chloride or POCl3 is formed here. Next is the aryl compound, and this aryl is reacted with this PCl5, and there is a formation of this as acetyl chloride is formed here, the benzyl chloride is formed here, and there is a formation of this methyl chloride plus your POCl3 is formed here. Next is the trans esterification. So in the trans esterification is the conversion of your carboxylic acid ester into a different carboxylic acid ester. And when an ester is treated with an excess amount of an alcohol in presence of an ether, either an acid or a base, there can be exchange of alkoxy group. So here you can see this is your ester, and when it is reacting with an acid or an alkali, there is a formation of the another ester. Means your alkoxy group is exchanged. So this is your trans esterification. So here you can see the ethyl acetate is reacted with this butyl alcohol, and there is a formation of this butyl acetate plus ethanol is formed here. So in this, the ethyl acetate is reacted with this butyl alcohol, and there is a trans exchange of the alkoxy group. So here the butyl from the ethyl acetate, there is a formation of a butyl acetate in the presence of acid or an alkali, and there is a formation of the ethanol is also formed here. So in the trans esterification, it is a conversion of one ester, carboxylic acid ester, into a different carboxylic acid ester. And when an ester is treated with an excess amount of an alcohol in presence of either an acid or a base, there can be an exchange of alkoxy group, and there is a formation of a means alkoxy group is exchanged in between the two esters. Next is the reaction with hydrogen. In this, the esters is reacting with the hydrogen, and there is a formation of an acid hydroxides. So here hydrogen are getting converted to the hydroxides. So here in this, the ester, when it is reacting with this hydrogen, and there is a formation of an acid hydroxides are formed, plus your ROH is formed. So in the uses, esters are used as solvent in perfumes, plasticizers, gums, resins, cellulose, paints, varnishes, oils, and fats. They are commercially used in making artificial flavors and essence. Next is your acid amides. So here in the acid amides, amides are least reactive derivative and of carboxylic acid, and they are also converted into carboxylic acid by acid or alkaline hydrolysis, and they can be dehydrated into nitrile. The important chemical reaction of acid amides are amphoteric character, and the amides are weak acid as well as weak base, and they are most basic than other derivatives because nitrogen is an effective donor of electron in comparison to oxygen, and they are neutral to litmus. So these acid amides, these are neutral to litmus, and these are weak acids as well as they are weak base, and they are the most basic than the other derivative because nitrogen is an effective donor of electron in comparison to oxygen, and they are neutral to litmus. So in the first, there is a basic property, and in this, the acid amides are behaving as a base and react with the hydrochloric acid to produce salt. So in this, you can see the acetamide is reacting with this HCl. There is a formation of this acetamide hydrochloride is formed here. Next is your benzyamide. So in this, the benzyamide is reacting with the HCl, and there is a formation of this benzyamide hydrochloride is formed. Next is the acidic property. So in the acidic property, acetamide as an acid react with the sodium or mercury oxide, and there is a formation of this corresponding salt, that is the acetamide is reacting with this sodium, and there is a formation of this sodium acetamide is formed here plus what hydrogen gas is formed here. Next is the hydrolysis. So in the hydrolysis, acid amides are not easily hydrolyzed with water but hydrolyzed easily on heating with dilute acid or alkali. So acid hydrolysis, these amides are reacting with water molecules and in the presence of an acid, if they are heated, and there is a formation of the carboxylic acid is formed plus ammonia is formed. Next is the acetamide is reacting with this water molecule, and there is a formation of this acetic acid plus ammonia. Next is the benzoamide, and this benzoamide is reacting with this water molecule, and there is a formation of this benzoic acid is formed plus your ammonia is formed here. Next, this is the mechanism. Here you can see the hydrogen proton is reacted with this OH, and carbon is having the positive charge. Again, there is a reaction with this water molecule, and hydrolysis is occurring, and this OH is reacted with this. And after that, there is a removal of H positive from that, and there is a formation of this carboxylic acid is formed here. This carboxylic acid, see this carboxylic acid is formed here. Means here this H is removed out from here, and with the double bond of formation is here. And this NH2 is removed out from here, and this NH2 will react with this proton, and there is a formation of this ammonia. And after that, when it is reacting, this H is removed out from here. There is a formation of this ammonia salt of acetate. Next is your alkaline hydrolysis. In this, you can see this acetamide is reacting with this NaOH, and there is a formation of this sodium salt of acetic acid plus ammonia. So here you can see the OH will react with this, and there is a formation of this acetic ion plus ammonia is formed. And next is the reduction. In this, the acetamide is reducted in the presence of the lithium hydrate plus sodium, or sodium is used, or alcohol. So there is a formation of this ethylamine. Next, benzoamide is reacted, and there is a formation of amine. Next is a dehydration. On reacting with phosphorus pentaoxide, there is a formation of methyl cyanide is formed here, or nitrile is formed here. And this benzoamide is also reacted with this P2O5, that is a phosphorus pentaoxide, and there is a formation of cyanide. Benzyl cyanide is formed here. Next is the action of nitrous acid. So this nitrous acid is reacting with this acetamide, and there is a formation of this acetic acid. Next is the Hoffman bromamide. So in this, you can see amides are reacted with bromine and alcoholic potassium hydroxide and from amines. So here primary amines are formed from this acetamide, and this acetamide is reacting with the bromine and potassium hydroxide, and this is a formation of this primary amine, potassium carbonate, KBr, potassium bromide plus water molecule is formed here. So this is Hoffman bromamide reaction or Hoffman degradation reaction. The uses of the amides are that it is used as a solvent for several organic and inorganic compounds. And this is also used as wetting agent, plasticizers, and clothes, etc. They are also used in making explosive and leather tanning. Next is the mechanism of esterification and hydrolysis. So in the esterification, the acetic acid is reacted with the ethanol in the presence of acid. There is a formation of this ethyl acetate. So this is the mechanism of it, that here you can see the proton is reacted with it, and there is a addition of proton on the oxygen atom. After that, this ethanol, which is this ethanol, so it will react with this carbon atom, and here you can see this is getting the positive. So from here, H is removed out from there. So H will remove out from here. Now again, this O will withdraw electron, so it will remove out from here, and it will react with this, and there is a formation of the H2O, and oxygen is also removed out from here. Hydrogen is also removed, and this bond is shifted to there. So here, double bond is formed, and there is a formation of this ethyl acetate. Next is the hydrolysis. So in this, the esters are not hydrolyzed easily with water, but hydrolyzed rapidly in acidic and alkaline medium. So this is the acid hydrolysis, and this is the alkaline hydrolysis. So in the acid hydrolysis, there is a formation of this acetic acid plus ethanol, and this is the alkaline hydrolysis. This is also known as a saponification reaction. In this, sodium acetate plus your ethanol is formed. So this is the mechanism of your acid hydrolysis, and this is the mechanism of your alkaline hydrolysis. Now is the question: anhydrides can be converted in ester with the reaction with alcohol. So reduction of acetyl chloride with BDSBASO4, formation of acetaldehyde. On reaction with Li, lithium aluminum hydride, there is a formation of alcohol. On reaction with thionyl chloride, esters are converted into acid chloride. Next, with lithium aluminum hydride, amide reduces to acid, and anhydride can be converted into ester with the reaction of C, that is your amines. So next is your acid amides. Sorry, acid amides are formed acid amides are formed from this. So then acid amides can be obtained by the partial hydrolysis of cyanides, and on reduction with lithium aluminum hydride, acetic anhydride produces is your alcohol. Next is your references. From here, these are the references from where you can study this topic. And thank you so much for this lecture. And this is the completion of this carboxylic acid derivative plus the carboxylic acid.